So let's talk about this extra credit stuff. So, and you see I've taken our spreadsheet, two things. I've brought it into Microsoft Excel because it's easier for me to be able to write some notes here on the screen. And I copy pasted and redid our data so it's a little easier to see. So you recall from class we had three measurements of the length, the width, and the height. And although something seems wrong here, no, it's all good because it's the difference that matters. Okay, and we then found the difference because we took a beginning and end, and then we subtract them, and each measurement had an estimated error, and then we did the difference, and then we did a calculation of the error on the difference, and we used this formula up here. And in that case, capital A was the first measurement and capital B was the second measurement, H1, H2, for example. And then little a and little b were each one. And then we always say that sigma AB is 0 for us. So we just use sigma squared A plus sigma squared B, which happen to be H1 and H2. And so, in fact, we see that right there. It's E17 and G17 squared, added, and square rooted. So then we were able to then take the three values of L, W, and H in each time. So that's the first value. So H5, and where's the H column? Right. So H5 times H11 times H17. So let's see. And H meaning this right here. So there's H11, oops, H11, and there's H5 times H11 times H17, and that is one volume calculation. Then there's the next and the next. So and we had three of them. We calculated the fractional error on V, and then we used this formula here. And in fact, we used the lower one first, and then we used the upper one to get the plus minus by simply multiplying the fractional error on V times the actual value itself. Okay. Now, we could take the average of this, and this is what we're talking about, averaging. And so, in my case, I quoted really large errors. And really, the bottom line of this lab is you'll notice there is, and I ended up with pretty large error. But when you use the true resolution of a millimeter ruler, you end up with errors that are even smaller than this. Because mine are large. You guys probably got something like 2.9 or 3.0, whereas I got a large number, 29, 30, and both at 30.57 and 30.02. Now, one thing you can do, and one of the techniques people do, is let's say we've got ourselves a pretty bad error here. This 0.2 is pretty bad if you're talking about a millimeter ruler. So what we can do is we can average the measurements. We took 3 heights, 3 widths, and 3 lengths, and then we can go ahead and then calculate the volume using those averages. So you see that's H8 and H14 times H20. And we get pretty much the same answer, and we should do a little exercise to see how that compares to the average of these three. We'll do that in a moment. And then I said, okay, we're going to calculate the error, the plus minus on the average. And I told you that the average, the plus minus on an average, well, first of all, let's make sure we know we are talking about the same thing. All right, so I did some, let's going to look at H, the average of H right now. So I want to try, the pen is a little cranky. Oh, there it goes. All right. I wonder what's going on there. So if we are looking at the height measurements, and so we have H1, H2, and H3, and that just means we took 3 measurements here. Let me pause this for a minute. All right, so we don't want to be confusing, so we're going to talk about H, we'll call it HA, and HB, and H3, and what C. So it's funny. C. And it doesn't want to cooperate. Come on. And C. So that's our 3 measurements here of H2 minus H1. So first of all, we should probably remember that H average, in this case, is going to be HA plus HB plus HC, and then we divide it by 3. And then I told you that the plus minus of H average equals to H average, no, excuse me, pause. I told you that the plus minus is to simply take the plus minuses on each of the H height measurements. So that is, so HA has a plus minus HA, and HB has a plus minus HB, and HC has a plus minus HC. And I said, oh, well, you just do the, you take the average of those 3 plus minuses, so then that is plus minus HA plus minus HB plus minus HC, and then you divide it by the square root of 3, because it's 3 measurements. So when I was getting ready to make this video, I started doubting myself a little bit. So I did a little back of the envelope, they say, or back check calculation. And I said, okay, let's think about H average and look at the original equation here. And I'm going to look at this guy up here that we used to get the plus minus on H2 minus H1. So I'm going to define A as equal to 1/3, because in here, see, that's this is 1/3. If I pull this out, the 1/3, and then I'm going to say that capital A equals is HA, capital B equals HCB, and capital C, which isn't up there, but you can always just add another one, is HC. And each time instead, and so if you like, we make that little b equals little c. Okay, so what then is the plus minus, which sigma is just another word for it? What is the plus minus h average? So we just say, oh, it's 1/3 squared times, excuse me, plus minus h a squared. We can put that like this if we like, because you see there's the a squared up there, plus 1/3 squared plus minus hb squared plus 1/3 once again squared times plus minus hc squared, and then I square root it. And you see how because a equals b equals c, I can pull that out. So it just becomes 1/3 times the square root of these guys. And I'm just going to use shorthand, sigma a squared plus sigma b squared plus sigma c squared. Now, this is what's pretty interesting, though. If we look over here, I want to get this pen unselected if I can. So this, no, it's not cooperating. Let's see what happens. So, first of all, here is the formula where I took the average of them and divided by the square root of 3. And now here is the formula I just devised. So it's the square root of 3 errors squared, see, I17, I18, and I19. And then I divide it by 3, just like I did here. And isn't that amazing? They're exactly the same. In fact, we can, let's do this. Let's make absolutely certain. Let's take the difference between them. And if it's 0, then that means they're exactly the same. I was thinking that maybe they would be just a little bit different. But yeah, look at that. Zeros all across. So now you see this is where it comes from. That and I just for the life of me oh, now let's be careful here. What did I say? Let's pause. So this is, that's the average. So we have to be careful. See, this is a little wrong up here. Because this is supposed to be, hold on, we need pen again. Nice. See, now I know things are bothering me. So this is actually here, and then that's divided by 3 because I have to use this. Similar to that, excuse me. If I want to take the average of these 3 numbers, then I have to divide by 3. And so let's make sure we see it because we did it in one step here. So you see here it says the average of I17 to I19. And so when it does that, it adds them together and then divides by 3. And now we're dividing by a further square root of 3. It's interesting. So I'm not going to get into a long algebraic derivation here. But anyways, this is this thing where you say, if you want to average So let's say you have a set of measurements and so in this case H, and then let's say we have a set and we have the general rule would be n, a set of n measurements. So in this case, n equals 3 of H, and each one has a plus minus H. So we can always take the average. So H average equals sigma, which just means adding H sub I, and I equals 1 to n. And so then you see how we get 1, 2, 3. And then we divide by n. And then again, in this case, it's 3. And then we said that the plus minus H average equals, excuse me, and just, I need to get the select tool back for a minute. I'm just going to cheat here and make this a little bigger. All right. And, oh, don't I have a pen? Yeah, okay. So the plus minus of H average, I said, was to take the average of the plus minuses. So that would be sigma of plus minus HI, I equals 1 to n, divide by n, and then divide the whole mess by the square root of n. And that's the general formula. And what we did now is we demonstrated that that formula is valid because, well, we didn't do a mathematical proof, but we demonstrated it was valid because we used the straightforward way of doing it, using the standard error propagation formula. And when we took the difference, they were exactly the same. So it says that it's good enough to simply take the average and then divide by the square root of the number of them. And then at the end of the day, we ended up, we calculated the length, multiplied the length, width, and height, the averaged ones, as I said, and then we took the new plus minuses of the averaged values, and then we did the standard error calculation there. There it is, see? And then that got us our fractional error, and then we noticed, lo and behold, we improved ourselves by almost a factor of 2. So, in fact, the square root of 3 is actually 1.7, so that's why it's almost 2. Isn't that interesting? So that's what averaging buys us. So we can, excuse me, you can always, in a pinch, take a bunch of measurements, get their average value, and then you can find out what is the new error by simply dividing the square root of the original errors by the number of them. And then there's one final thing. What if, now we calculate, I'd like to know, and so I'm going to insert a row here, and insert, and I want to see, I want to take insert. So let's go ahead and let's take the average equals average of these three guys. So it's not a lot different than this one down below. And now what do we want to, we say that we can take the average of, excuse me, we can take the average of those three. Equals average of those. Now in this case, this is the fractional error, so I'm embarrassed to admit that I don't remember if that's valid to do this here. And then, but let's get the plus minus. We know this is valid. So this is going to equal average of these three. And then I'm going to divide by square root of 3. Enter. So either way works, huh? Interesting. All right, so for the extra credit, you want to talk about averaging, and in the report, you should write something up in your logbook. That's a good researcher would always do it. So you say, look, we were told that we can grind out the using these propagation formulas. What's the plus minus on an average? But there's the shortcut formula, and we demonstrated that it's okay to do it. So we took average values of length, width, and height and calculated their plus minus. And then we calculated from those average values of length, width, height, we multiplied them together, get the volume. And then we did the standard error propagation formula here by taking the fractional error that we calculated, and we ended up with this, and then we multiplied the value times the fractional error, standard technique, we got a plus minus. And we did better than when we got an improvement. Yeah, I'm doing two things at once. So then we went ahead and we decided to double check. We took the average value of our 3 volume determinations, and that's that. Then we used the Then we used the this formula we derived here, or we used earlier, and we used it here. Nope, excuse me, here. Oh, escape. I'm overriding myself. We used it here, average of those, divided by square root of 3, and we got pretty much the same answer. So one thing that it shows is you might as well just take the average of the result, because you're going to get the same thing as if you did the average of if you did the volume calculation from the averages of the original measurements. So one final thing I wanted to see. Oh, yeah, these two are exactly the same. Isn't that something? Okay, so that means that this formula is valid after all, even though you see they're different. Wow, isn't that something? Coolio. I have to go and do some paper scratching. Okay, so anyways, there you go. I should make a screenshot of this, and I'll post it, this final spreadsheet. But you'll have to, if you want the extra credit, don't forget it's 15%. You'll have to fill out the spreadsheet like this, and let me see it. Post. Let's see. Yeah, you would just you can put into the report the tables like this, and then some explanations of the calculations. Yeah, if you know how to enter equations, but If you want to try doing some copy paste here, that's fine too. Very good.